Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 7 of the December daily Leetcode challenge and we have a very good question in front of us. Compared to previous days, I will say this is on really on a harder level compared to the previous medium question that we have seen. Till now we have seen medium question on the easier side, but this will be something that will be on the harder side. Okay, let's see this question. Here we are getting to learn a lot of concepts, especially the use of binary search. Okay, it will not appear as such, but internally we are going to use binary search to get the optimal solution. Let us begin this question. It is 1760 minimum limit of balls in a bag. Okay, so if you see the input, basically what is given is we are given a nums array. Okay, let me show with example 2. So basically we are given a nums array and the second input given is the max operations. So let us see the question now. So basically what is happening is you are given integer array nums where ith bag contains, so these are basically number of balls which are there in the bag. Okay, each one of them represents a bag and the number here represents, that is the value in this, represents the number of balls in that bag. Okay, that is what they're trying to say in the first line. Fine, you can perform the following operations at most. That they're mentioning about operation, that operation can be performed at most this many number of times. Okay, so this will be input to us. If you see, this is going to be input given to us. Okay, now what is the operation? Take any bag of balls and divide it into two new bags with a positive number of balls. For example, let us say we are taking a bag which has 5 balls. So what we can do is we are going to divide those fives into two. It can be done in any way. For example, that five I can divide into in the ratio of 1:4. Okay, so when the first bag will have the one ball and the second bag will have 4 balls, and similarly I can do in the ratio of 2:3. Okay, so the first bag will have 2 balls and the second bag will have 3 balls, and anything like that you can do. Okay, there is no restriction as such. If you see, they're just saying that it has to be a positive number of balls. Okay, it just they're saying it has to be positive. That is, five you cannot simply break it into 0 and 5 again, because one will have zero. Zero will not be considered a positive number as such. Okay, so they're just saying that it has to be a positive number, as simple as that. You cannot use negative numbers as well. So fine, that is the basic thing. This is going to be operation. This operation you can perform for at most this many times. Okay, which will be input to us. Your penalty is the maximum number of balls in a bag. Okay, so the idea is after doing all this, for example, what is happening in this, if you see, the bigger number is being made into, that is the bag which has the more number of balls is being reduced. That is, we are dividing that bag into two bags, thus reducing the balls in that. Okay, so the ultimately what we have to do is we have to see the penalty is the maximum number of balls in a bag. So what idea is we have to reduce the maximum number present in any bag. Okay, that is the basic idea. You have to minimize your penalty, so return the minimum possible penalty after performing the operation. So idea is very simple. We have to reduce, that is we have to minimize the max number of balls present in our any of the bags. Okay, we have to minimize the max number of balls present in any of the bags. Okay, for example, in this question, if you see, in this this is going to contribute to the answer. Okay, why? Because 8 is the maximum number of balls that are present in any bag in this particular input. Okay, so this will be the answer if we don't apply any operation, but we can apply certain operations. So we'll have to apply those operations and then we'll have to reduce it in such a way that we are getting the answer finally. You can go through the examples. So if you see here what they're doing, they're at first taking 8 because it is the maximum one, and then they're dividing it into 4 comma 4. Okay, the it is being made into 4 comma 4. Okay, as simple as that. Then we are left with three more operations. In each of those three operations they are targeting these. Okay, they're targeting these three ports. Okay, and then all of them are made into 2 to 2. Okay, so that ultimately we are we are getting this. So the answer is going to be 2, because 2 is the maximum number of balls left in any bag after applying all these operations. So 2 is going to be the answer. Okay, this was the example 2. If you come to example 1, we are given a single bag which has 9 balls and we can apply two operations. So in the first operation, what I'm doing, I am making it as a 6 and 3. The second operation, I'm making it as a 3 and 3. Okay, that 6 is being distributed into 3 and 3. So at last, 3 is the highest number of balls present in any bag, so 3 is going to be the answer. Okay, that is the basic idea. So what we did, we minimized the maximum. That is, 9 was the maximum here, we minimized into 3. Okay, now 3 is the maximum, so we minimized the maximum. Okay, that is the question. If you see the constraints, basically it is going to in the range of 10 power 5. Okay, the length is going to be in the range of 10 power 5. The values are going to in the range of 10 power 9. Remember, these things will also play a role, especially in this question. See, normally what we do is only the length matters to us. Okay, but in this question, even this particular thing, okay, the single value, how big it is, that will matter in this question. Okay, we'll see that how. So this question, if you try to solve it in a brute force way, it is going to be, it's going to exceed the time limit. So you have to understand trick here. Without understanding the trick, you cannot solve this question. Okay, so let us see the trick now. Trick is going to a simple mathematical thing. Okay, there is nothing much fancy here. It's going to a single mathematical thing. So let us quickly begin this. I will just show you the trick and then we will start the code. Okay. So what is happening is, let us say a ball has a balls a particular bag has 5 balls, okay, and in this case maximum number of balls allowed is 2. Remember, this particular thing is not given to us, okay. This is something that we are going to introduce. Remember that max balls allowed in a bag, okay. This is something that is not given. If you see in the input, basically in example 1, we are given only the nums array and we are only given the max operations. They are not mentioning anywhere the max balls allowed. Remember that this is something that we are going to introduce. This will tell that what I see idea here is max ball basically means that if a particular bag has more balls than this number, I will have to shelve that out. Okay, simple. I will have to apply certain number of operation to that bag until and unless the number of balls is reduced to less than this particular value. Okay, less than or equal to this particular value. Okay, as simple as that. So currently my bag has 5 balls. Remember, single bag has 5 balls, and the max balls allowed per bag is 2. Okay, so what we have to do? We have to apply certain operations to this 5. Okay, what I'm doing first? First, what I'm doing is I'm applying this operation. Okay, what I'm doing, I'm distributing 5 into 3 comma 2. Okay, that is 3 plus 2 is 5, so we are distributing into 2 bags, one having 3, one having 2. Then what I'm doing, this particular 3, basically I'm going to break it down, okay, into 1 comma 2. Okay, so what is the final thing now? We are having 1 comma 2 comma 2. Okay, this is the basic thing. Now how many operations we needed actually 2 operations. If you see, the first operation made it into 3 comma 2, the second operation made the 3 into 1 comma 2. Okay, so basically needed 2 operations. Two, see, remember our aim is very simple. The maximum also allowed is 2, so anything less than this we have to reach there. Okay, as simple as that, with the minimum number of operations. So this is how we are going to do that. 3 was something that was exceeding this particular limit, so we again distributed 3 into 2 bags and we got this 2. Okay, so total number of operations to do this, that is to achieve max balls allowed equal to 2, is in this case is 2. Okay, so let us see how to get that mathematically. So in this case the number of operations is 2. You have to agree with me, okay, in this. Now the thing that you have to learn here is how to get this number 2 without doing all the simulation directly. So what they're doing is, see, you'll have to use a seal function. Seal of 5 divided by 2. What is 5? 5 is the number of balls in the bag. Okay, 5 is the number of balls in the bag. What is 2? 2 is the maximum numbers allowed, and maximum balls allowed per bag. So 5 divided by 2, you have to take the ceiling of that. What is ceiling? Ceiling means the next biggest number, next nearest integer. Okay, for example, 5 divided by 2 is 2.5. The next biggest nearest integer is 3, so it will be rounded to 3. Then you have to 3 minus 1, which is 2. Okay, so we are getting the answer is 2. This 2 and this 2 are the same. Okay, so we are going to do this way. Okay, we are going to do this particular formula to get the thing. Okay, so I hope you are understanding this. What we are doing is, see, the number of balls we are taking, we are dividing by the max balls allowed. Okay, then we are doing a minus 1. Now you will ask me why I'm doing minus 1. See, the idea is very simple here. What is happening is, see, this 5 we are breaking to 3 comma 2. Okay, now only this 3 you are going to break it further. Okay, so if you see what is happening, basically seal, basically see, the idea here is it is when the last number is being retained, okay, as such. So after this 2 we are not going to apply anything more, right? Only this 3 we are going to apply, break it down into this. That is the reason why we are basically doing a minus 1 here. Okay, so that is something that we are going to do now. So let us quickly begin our solution. What we are doing, see, answer is going to be very simple. If you see on a rough scale, if you want to try to the answer is going to be, see, first of all, see the constraints. This particular thing, okay, nums of I, the minimum value in this is going to be 1. Okay, and can you quickly tell me for each question what is going to the max limit? The max limit for any question that is the answer is going to be the highest value in that. Okay, so our answer is going to lie between 1 and the highest value present in nums. Okay, so basically I'm this inspire us to start a binary search. So if you see here, this is what I'm going to do. I'm going to start a binary search here. Okay, so what is my lower limit? Lower limit is going to be 1. Why 1? Because if you see, this is the value 1, the minimum value for nums of I. Okay, now what is the maximum value? Maximum value is going to be the maximum value present in this particular nums array. Okay, so this is going to max of nums. Okay, as simple as that. Then what I'm doing, I'm starting the binary search. Okay, till lower, that is the lower limit is less than the high limit, this particular function will this loop will run. What I'm doing, I'm taking the mid value of them. Okay, see, there are multiple ways to take the mid value. Some will do in different way, that is they will do L plus H divided by 2 and something like that, but I prefer doing this. Okay, L plus H minus L divided by 2, that is integer division. Okay, as simple as that. And then I will check this function. I am yet to display it to you. Okay, I'm yet to explain this function, so I will come to that later. But what I'm doing is, I'm just passing this mid. Okay, what is this mid? Basically, this mid will tell me that what I'm going to check is that if, let us say, the max limit, okay, there is a max ball allowed, is going to be this particular value, which is mid, and then I will see how many operations will be needed in that case to make all the balls less than or equal to this particular number. Okay, that is the max balls allowed per bag is going to be if this number, then how many operations will be needed? If that number of operations is less than or equal to this, then we are good. Okay, then this particular function will return a yes, that is a true value. In that case, this could be one of the possible answers. So what we'll do, we'll just do h is equal to mid. Remember, normally we do mid minus 1, h equal to mid minus 1. In this case, we are just doing h equal to mid, because remember, if you do minus 1, remember, minus 1 may not be answer. Remember that mid minus 1 may not be answer, so we have to stick to the right answer. So we are doing h equal to mid. Okay, in the else condition, what we have to do, we have to do l equal to mid plus 1. Okay, see, I hope you are understanding binary search, because this, I am assuming that you know this, because I'm not going to the in depth of it. The idea here is we are like reducing half each loop in this, basically reducing half of the search space. Okay, as simple as that. If this number is possible, then what we are going to do, we are going to try even smaller value. Okay, that is, I am reducing the height to this. That is, now the search will be between L to mid. Okay, as simple as that. If this is not possible, what I have to do, I have to expand my limit. That is what I'm doing. Now my search will be between mid plus 1 to high. Okay, as simple as that. So this is the basic idea, and this loop will keep continuing till L is less than H. And if nothing happens, that is, once we come out of this, we have to return L. Okay, remember what happens. Let's see, if we are getting a first value H. That is, if it is possible, only then H will have this value. After that, let's say all of the terms are not possible. So what will happen is L will keep approaching H, and finally, when L is less than H, this L is equal to H minus 1, let us say. Then finally, this will happen mid plus 1. So L will become H finally while we come out of this. So basically, L and H will be same, and when we are returning L. Okay, this is the basic idea. Now let me show you this particular function is possible. So the same thing that I explained, it's doing the same. It will basically check that this is going to the max balls allowed in a bag. Okay, I am just going to see, to ensure that any bag is going to have this many number of balls, how many operations do I need. If that total number of operation needed is greater than the max operation given in it as input, in that case I have to return false. Okay, in that case I have to return false, otherwise I will return true. This is the same thing that I've showed you below. Okay, this is the same calculation that I've showed you below. Okay, let's see this first. So I'm declaring a variable called total operations, which is 0 initially. Then I'm going through each of the numbers. What I'm doing, if the I is greater than max balls in a bag, that is this particular number. Okay, max balls in a bag. Remember, only if it is greater, we have to apply certain number of operations. If it is not greater, it doesn't make sense to apply any operations. Okay, as simple as that. If it is greater, what I'm doing total is equal to that is total operations is equal to total operations plus seal of the division minus 1. Okay, seal of the division minus 1. Why this particular thing is coming, I've already explained it here. Okay, why those things are coming, I've already explained you here. This is something that is tricky, as I mentioned. You'll have to figure it out by your observations. Remember that these things are slightly tricky. I understand that. I totally agree with that. But these things, you should be given some hints by the interviewer if you're facing this in a face-to-face interview. You have to come with the approach. But yeah, these are slightly some of the things where the interviewer should be giving you certain hints to reach here. Okay, because these things, you have to learn by your observations only, and by the hints given by the interviewer only. Okay, that is the way around. So yep. But then we are doing that, where see how many operations are needed for each number. Basically, we are storing it in this particular value. Okay, then once we come out of the loop, that is, once we have ensured that all the numbers are now less than or equal to this particular number, then we are checking for ensuring that how many operations are it took. If the number of operations is greater than the max operation, then it is not possible, right? We have written false in that case, otherwise we have written true. Okay, so that is basically, this loop will keep continuing. And since whenever it is possible, I'm reducing the search phase. I'm trying to look for a number even smaller than that. If that is not possible, we are ultimately getting this as the answer. Remember that. Okay, ultimately what will happen, L will become H. Okay, at last, because see the conditions here, L will be H minus 1 in the last iteration, and then L will become H. Okay, so that is the basic idea. Finally we'll be returning L. So I've already segmented this solution and it got accepted. Okay, in this, yeah, I agree that this is something very trivial case. Okay, here there is not much for us to, there are not multiple approaches that we can use it to discuss here. I agree with that. But yeah, remember, binary search is something, which is very, underappreciated concept. It, applies to a lot of problems. It makes the problems very, very simple. And coming to space and time complexity of it, see, the idea is going to be very simple. First of all, we have to understand that, let us say, that's why I mentioned the starting of the question itself. In this particular question only, see, this is one of those questions where even this value will matter. Normally what we do is we take the nums length, that is the length of the array given to us. We take that and analyze the complexity. But in this question, even this will matter, because this is the nums wise going to be in this range. Okay, so let us see that what happens. So let us say k is equal to the max nums. Okay, that is the maximum value in the nums array. Okay, is k. So in that case, if you see what we are doing, see, the binary search will basically take log k time. Why log k? See, the binary search is going to happen between 1 till k. Remember that. Okay, that is 1 till k. So it is going to take a max time of log k. Okay, that is, you can say, log k iterations are going to happen on a whole. Okay, approximately log k iterations. Now for each iteration, basically we are going to call this function. Okay, so how much time is this function going to take? This function, if you see, is what it is doing is basically, going through each of the numbers in the nums array, and it is doing a constant, it's doing operation in a constant time. Okay, just the division, addition, all those things as subtraction. So basically this whole operation, this whole function basically is going to take O of n time. What is n? N is basically the length of the numbers. Okay, length of the numbers time. So now what this, uh, binary search is going to take log k time. In each iteration of the binary search, we are going to call this function, which is going to think n time. Okay, of n. So on a whole, it is going to take off and into log k time. Okay, as simple as that. And coming to space complexity, we are not using any such data structure here. Okay, because of which the space count will be constant. Okay, space count is not going to be dependent on the input civil length. Okay, as simple as that. So it is constant. So yeah, that was all for this video. I agree that this question was slightly on the difficult side, because only if you get the hint you can solve this question. I agree with that totally. But remember, at least if this comes in an interview, face to face interview, you should be able to code the brute force solution at least. At least this should come to minds. Remember that if you are seeing a question where it's not mentioned, right, written -1. Okay, if they mention like if nothing is possible written -1, then that is fine. If they do not mention that, that means there is always going to be answer. Okay, if that is the case, you have to analyze what is the range of the answer going to be. Okay, in if that is going to the first hint to apply the binary search, remember that. So that is something that we have to start with. And because yeah, in this question I agree that this particular idea of introducing this, okay, that is a max balls allowed, okay, per bag. This idea, if you only if you are introducing it, then you will getting to the solution. I agree with that, because as such they are not giving any hints to this. Okay, I agree with that. But yeah, there will be hints given to you during the face-to-face interview, and you will have to come to the solution. So yeah, fun, that was all for today. This was the first question that I will say is slightly harder in the December Daily Code Challenge we have seen till now. Okay, that is all the questions we have seen till now in the December Daily Code Challenge. So yeah, fun, that was all for today. See you tomorrow. Thanks a lot.